All right, classifying numbers. They have a lot of this on the MCA tests, and we've talked about it before, so you probably remember it, or maybe a little bit. If they say a number is a real number, the abbreviation for that's a capital R with two lines like that.
Looks like a pie.
Yeah. Real numbers is just every possible number. So if they tell you something's a real number, it doesn't narrow it down for you at all. It means it can be a square root, it can be a decimal, a fraction, a whole number, a negative, anything. It can be a repeating decimal. So real number just means it can be any kind of number. But then the real numbers are split into two categories: the rational numbers and the irrational numbers. So we've talked about these before, and they have a ton, well, I shouldn't say a ton, but probably at least 5 questions on the MCA test classifying if it's rational or irrational. So if you remember this, they're easy points to get. The definition of rational is can be written as a fraction. Most everything can be written as a fraction. The definition of,
You weren't recording, were you?
yeah, it was.
Oh.
I think it was. The definition for irrational is decimals that go on forever without repeating.
So pie.
Pi. So what that means then is repeating decimals are rational. Now this is the easiest way to remember this. Irrational, the most common one, is pi. The other ones you guys got to deal with are the square roots that are not perfect squares. Square root of 2, square root of 3, square root of 4 is rational because it's 2. And you can write that as 2 over 1. Square root of 5, square root of 6, square root of 7, square root of 8, square root of 9 is rational because that's 3, which is 3 over 1. You guys remember the perfect squares?
Yeah.
4, 9,
16.
16, 25, 36, 49, and so on. 4 times 4, 5 times 5, 6
Was it
times 6.
81? That's 9 times.
Yep.
No, Carly.
Anything right, like any of the.
Anything times itself. That's what a square root is. So all the non-perfect square roots are irrational. Because if you did this on a calculator, it would give you a long decimal and nothing would repeat. Obviously it would stop, but it would never repeat. Okay? So that's the easiest thing to remember about these. If you have something like this, the square root of 18 times the square root of 2, and you had to classify that, this is why we had to learn stuff about the square roots. Remember, if they're both underneath, you can multiply them. So that equals the square root of 36, which equals 6. So is this rational or irrational? Rational. Okay. Then the different types of rational numbers. These are just the irrational. There's no other subsets. But in rational numbers, they have natural numbers.
What's that?
Natural is at the beginning of time, all they did was count sticks. They counted 1 stick, 2 sticks, 3 sticks, and so on. They didn't even know what 0 was. So then, whoever it was then came up with the whole numbers, and all that is it's the same as the natural, but they knew what 0 was. If you had nothing, it was 0. The easier way to remember that is in whole numbers, the first number has a hole in it.
Oh my gosh.
Okay? Then there is integers. Integers means no decimals or fractions. And when they developed the integers, all they did is they discovered negative numbers. So the integers is just the whole numbers and the negative numbers, but no fractions or decimals. Now of these, I think the only one you really need to know is that one for the MCA. And all this is if they tell you to find the integer, it's kind of giving you a hint. If they say find the integer, that means you're not going to get a decimal or fraction. So if you solve the problem and you get a decimal or fraction, you know you did something wrong, because if they say it's an integer, you won't get that. Okay? So today we are just classifying. And estimating. So, classifying each real number, remember a real number just means it's any kind of number. Square root of 12, what kind of number is that? It's irrational. And there are no subsets. Irrational numbers are just either irrational. If it's rational, there are these subsets. Whole numbers, natural numbers. Negative 0.25 repeating. That is rational. Any number that repeats is rational because you can write it as a fraction. 0.25 repeating is 25/99ths. If it's a repeating decimal, you put it over 99 instead of 10 or 100 or 1,000. You put it over 999 since there's two decimal repeating. If you had 0.625 repeating, that would be 625 over 999. Three decimals, 3 nines. So this doesn't have a subset either because it's a decimal. It's not a whole number, natural number, or integer. Negative square root of 9 is rational because it's equal to negative 3. So what subset is that? Integer. 72/4 is rational because it's a fraction. 72 divided by 4 is a whole number. It's 18. So that means there's more subsets. It is a natural number, and you can just put a capital N for that. It is a whole number, and it is an integer. Anyone remember, I've shown you this before, the abbreviation for integer?
Wait,
I think those two.
Numbers are integers. That's a clue.
Yes.
Huh?
Z.
Z. Z is the abbreviation for integers for some
That's
reason.
confusing.
Yeah.
Well, because a 1
And then pi is the most common irrational number there is, and there are no subsets for that. So, to classify this, square root of 15. Is it rational or irrational?
rational.
Irrational, because it's not a perfect square. 0.35, rational or irrational?
Rational.
Rational. Because you could write that as 35/100ths. Again, the easiest thing to remember is the non-perfect square roots in pi are irrational. Every other number is going to be rational. Yeah. No, I don't. Yeah. Now, estimating. They're going to have a couple of these on your MCA test. The first segment doesn't have calculators in it.
Dang.
So, square root of 71. When you estimate that, you got to figure out what are the two perfect squares on either side of it. So, remember the perfect squares are 1, 4, 9, 16.
45.
Yep, 1 times 1 is 1.
36.
36, 49, 64, 81.
9.
Right there. The square root of 71 is between 64 and 81. Those are the two perfect squares.
8.5.
This is 8 and this is 9.
8 1/2.
So which one is it closer to? Is it closer to 64 or 81?
81.
Right?
Oh, yeah.
Because this is 10 away and that's 7 away. So it's going to be less than 8.5, right?
8.25.
I would say 8.3 might be a good guess, or 8.4. It's an estimate, so neither one would be wrong.
Wait, so we can't get it wrong if we guess?
If, as long as you're close. It is 8.4. But all you want to do is get it either exactly, if it's right in the middle, then it'd be 8.5. If it's less than the middle, then you put like that. If it's more in the middle, you'd put like 7 or whatever.
So if you put like 8.3, it wouldn't be wrong?
No, because it's an estimate. And again, if they rounded to the nearest integer, we know that this is less than half. It's closer to the 8 than the 9, right? So you would round it to 8. The nearest integer, you'd guess 8.3 would be a good guess, but 8.4 is exact, but it's just an estimate. Okay, square root of 23 is between square root of 16
25.
and square root of 25.
So 4.6.
So the nearest integer,
4.7.
it's
Yeah.
closer
4.6.
to 5. And then the nearest tenth, it's pretty darn close. 23 is close to 5. I'd say 4.8 or 4.9.
It's 4.85.
It's 4.8.
And 4.8 for real.
4.85. 4.8585. No, it's just 85.
Okay, comparing, now this is one where you probably would have a calculator when you're comparing, but maybe not. 2 2/3 is 2.6 repeating. Square root of 5 is 2.2. Now that's rounded. It's 2.2360667. So when you compare on these, you can just put greater than, less than, or equal to. Square root of 5 is less than 2 2/3. Okay, so
I have you guys
on page
Really, I'm making fun of Mike.
313.